This is the Amp Hour Podcast, recorded April 8th, 2012. Episode 90, Chaffered, Chocolate, Coemption.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
Hey, Chris. What's happening?
Hey, Dave. Happy Easter, man.
You know what the only good thing about Easter is?
Candy. Candy.
What's this American candy rubbish?
We just eat sugar nonstop around here.
Cheap Chocolate Monday.
You're saying you don't call it candy? Is that what I'm saying?
We don't call things candy in Australia.
What do you call it?
They're lollies. If it's actually like as in talking about hard candy stuff.
No. The candy is a blanket term. It's an umbrella term for all things sweet and bad for you.
Right.
Yeah.
Okay. No, we call it. If it's chocolate, it's chocolate. If it's if they're lollies, they're lollies. If they're chips, they're
lollies.
Lollies. Yeah.
Chips, you said?
Oh well, no. That doesn't come under the same
like French fries,
umbrella.
Isn't it?
Yeah, that's right.
Yeah.
No.
Okay. Well, that's all right. Cultural differences. There we go. Mark one down, people.
But it's as far as I'm concerned, it's Cheap Chocolate Monday. That's when
Cheap Chocolate Monday.
Yeah. That's when you
don't
buy the excess stock.
Yeah, you don't have the benefit of having coworkers. I don't know. Maybe at your new office you do, but at my office it's just going to be like free for all. You'll see buckets of candy sitting around,
right?
Or chocolates, as you say.
Right.
It's a very dangerous week back from work, I have to say.
Right. You can't resist, huh? Don't bother. Just let yourself go. You're a nerd and you're married, so who cares?
Yes. Stereotypes abound.
Yep. You betcha.
Yeah. I'm trying to eat a little healthier. You eat healthy all the time anyways, don't you?
I eat healthy 90% of the time, and 10% of the time I go ballistic. Yep.
Yeah, you go the other direction, straight for the junk bin.
You bet.
That's good.
Much to the wife's disgust.
Oh, yeah, well, she doesn't have to know.
I know, exactly.
Just slip away to the drugstore and buy a couple packets of candy.
We don't go to the drugstore, we go to the chemist. And what do you buy
weird.
at the chemist? You don't buy candy at the chemist.
No?
No.
It's just like a
to you, a drugstore. See, a chemist is a chemist. They sell drugs, right? They sell.
No, to us, a chemist is a guy that sits in a lab.
Yeah, exactly.
And pipettes stuff. Right?
Well, to you, a drugstore is something that sells everything, right? Including drugs.
Yeah, including prescriptions.
Yeah. Whereas a chemist here pretty much only sells, products. They only sell pills, medicine, all that sort of stuff.
Yeah.
So no, if you want to go,
candy then.
So you're really talking about a convenience store, really.
Oh yeah. Those really got smushed together around here.
Right.
So.
Yep.
And they're everywhere.
You
can get candy anywhere. Oh yeah. The key is getting in there at 8 o'clock. So if people are listening to this on the drive to work, turn your car around, get to your drugstore or your convenience store, and get there before all that 75% off crap sells out because, you need it.
See, they're not even called convenience stores here, really. Although that term
just told
has
me
been.
That was,
yeah, I know, but I was trying to, because I knew you wouldn't understand newsagent.
Newsagent, okay.
Newsagent. See, that sells papers and they sell candy and stuff. That's, although we do have, 7-Eleven and convenience stores like that in quote marks. All this American stuff has infested our country.
Oh, yeah.
Big time.
And it's delicious.
Right.
Infestation of Slurpees.
A Slurpee. Oh, goodness.
Oh, we could go on forever. We should probably talk about electronics at some point. What do you think?
Yeah, we should. Okay. What have we got on today's show?
Oh, lots of good stuff. Lots of electronics. And I should point out, our first piece of news / shout out, I'm going to say it myself. We are going to talk about more electronics on this show.
Are we? It's news to me.
Yeah, we are. Yeah, okay. You know why?
Why?
Because I have a new podcast about electronics, about engineering and the lofty engineering topics that I sometimes drift into around here.
And when does this start, and what's its name?
It has no name. I took some good notes from this Aussie bloke I know that told me, yeah, you don't need a name to start with.
Just do it.
Yeah, you just started, yeah. And that's actually what our first show was about, just getting it out there. So, got an engineering themed. It's going to be just about, I don't know, because Jeff, my cohort, is he's a mechanical engineer, and, I do electronics, so we're just going to talk about projects, and we'll try not to make it boring. I don't know. Like projects like the ins and outs of being an engineer, like
right.
the lofty... I don't know.
Right, you have no clue.
I have no idea. We have no idea what we're going to do with it. Yeah.
Folks.
But we're going to try it anyways.
Tune into the No Clue Show. With
the No Clue.
Chris Gamble and...
Yeah. The king of No Clue.
I thought that was me.
No. You're my humble assistant. I rule the no cluedness.
Does it even have a website? Where's it going?
No website yet. No, I'll link people to where the first one is, and we'll get a website eventually. But
all right,
just got to try it out,
Good luck.
And the idea behind it, though, is that we can, I'll shut up about that stuff on here, so we can talk more circuits and electronics and projects, and kind of tamp down that sensation I feel that I need to talk about the project side of things, or the like the scheduling and Gantt charts and all that crap.
Blah.
I won't actually talk about the Gantt charts, but
Gantt chart Smant chart. God, I can't even say
it. Yeah, so I got a new one. So that's 2 now, and eventually I'll figure out that
episode,
I need.
Is it?
No, I mean I've got 2 podcasts.
2 podcasts. You do.
No, this would be the first one. I don't know if you've heard about the Amp Hour.
Someone mumbled some shit. And then,
have you heard about it? Yeah.
I don't know.
Okay.
Don't think it's very popular.
Yeah, I don't either. All right, so you put... that's enough about me. Enough about me. What about you?
What'd
you put on here?
Well, I got a shout-out this week to Gizmo U.
Gizmo U?
Gizmo's
for you. Okay.
Gizmo for You. It's a website, gizmoforyou.net. And they've developed, over there, this open source, wank word, bingo time, open source remote control RC controller thing, with the joystick thingies that controls your quadcopter or your plane or whatever. And it looks freaking awesome. It does. Totally professional. And I think they've been working on it for many years, right? And it's got fully molded custom cases and the switches and the joy. You would swear you're buying this from a professional manufacturer, and it's an open source hardware thing. I'm not actually sure if it's a kit. I don't think so. I think it's actually sold, built up. But it is open source hardware, and apparently the info's the source code isn't up yet because it's so freaking huge that I don't know, they haven't figured out how to put it up yet or something. But it is, but all the schematics are there, and apparently, and all the mechanical design. So I would presume, so they claim. So I would presume that includes the 3D case mold-ins and everything else, and the PCB and stuff is all there.
And this is actually, so this is the place you can buy it at gizmoforyou.net, right? But the site itself, I think, is os-rc.com. Isn't that the...
Oh, okay.
The design site.
Be. Okay.
I think that's what you had told me. Because you had told me about this previously.
I did.
Someone else suggested it to us, I think.
This is the only one I put on the thing. So anyway, we'll fix that link if it's on the site. It's impressive. I mean, I've always kind of wondered that because, you see quadcopter kits and RC planes and everything else. And I was like, well, how much more is it for the controller? Because you always have to have that kind of component. And you got to program that side of things. And well, they can be very cheap. The one for my quadcopter, I paid $60.
Oh, interesting. Okay.
And that included the transmitter and the receiver as well.
Oh, wow. Okay.
Yeah. It's sort of hackable. It's got an AVR in there, and and it's got an LCD and everything. And I mean, you can really feel that it's worth $60. It's not exactly the
not
best,
in a good way.
It's not exactly the best quality of all time. But if you want to, I just wanted a cheap ass controller for my
for my
go left, go right,
just
to try
go down.
out. Yeah. So Yeah, for $60, geez, couldn't go wrong. This one's very expensive, though, by the way, I think.
Yeah, it's like €600 or something like that.
Yeah, something like that. It's not cheap. But, hey, because they're not, mass-producing them, making 100,000 of them out of China. So,
right, and this thing it looks got all the bells and whistles.
It looks the duck's guts. Yep.
Yeah. But, I mean, I'm guessing the screen is for sending video back to it, that kind of thing, or maybe actually the control. I'm not sure
if it's video capable or not, yeah. But, I'm sure they would have thought about that because it's supposed to be the be-all, end-all controller, And I don't know, is it like the most complicated open-source hardware project currently available?
Maybe.
I don't know. The guy who sent it to me said it's got an 8-layer board and it's, it's pretty advanced and it took many years to develop and and
there's a lot of cost in there.
There's a lot of and just the plastic moldings. How much effort would they have put into that? Because there's not just one molding. There's many different parts that go into it.
If he's pulling, injection molded pieces, that's creating. If people don't know about that stuff, I've only started to learn about that stuff. And man, a mold can cost tens of thousands of dollars. Because you have to get those. If the cheap ones are made out of like wax and like real softer metals and stuff like that, but if you're gonna do lots and lots of pieces, you got to do it out of like steel.
I know. Otherwise, they wear out. After 10,000 pieces, if you use a wax one or something, or a wooden something. I think there's many different types. I'm sure someone will correct us on the different types of.
If any mechanical engineers are listening, they're probably screaming and hitting their iPod or
speakers. But there's many different types, and they wear out. That's a very common problem. Your mold's worn out and you start to, your product. I can remember this back in the late 80s, early 90s, we'd start getting products in and all of a sudden, the plastic wouldn't look all that nice anymore.
It starts to round out a little bit and your company's logo looks a little wonky.
Exactly. It was because, your mold's wearing out. You're going to have to, fork up another 10, 20 grand. Thank you very much.
Yeah. I mean, it's basically because you're pulling molten plastic into this thing thousands of times
and
over.
Then it pops out. And that's
you
why
try doing that in your hands a couple times.
Yeah, and you've got to have like a vent hole, and that's why if you look inside any molded case, it'll have like a little plug thing on it.
Yeah,
that's where the air came out for the, And sometimes they'll chop that off and file it flat or something like that. And it's always on the inside. Right. You wouldn't put it on the outside of the case, of course.
Yeah,
you have to design your mold.
Another reason for people to pull stuff apart, it's always interesting to see that kind of point and just see the design side of it, because if you start, it limits you too on the injection molded side of things versus like a 3D printing kind of side of things. If you're 3D printing, you could do some crazy shapes. You can do overhangs and everything, and you can do ins and outs and lots of intricacies. If you're injection molding though, you have to be able to pull that mold off of something, and if it doesn't, if you can't get the metal out, then you can't do a lot of crazy things.
There's an art to designing injection moldable cases. You can't just do anything your mind thinks up. You've got to. There's a lot of practical considerations which go into it.
Yeah, a lot of DFM, that kind of stuff. They design for manufacturing. Yeah, and I wish I would have known about that when I was, even when I was starting about electronics. I wish I would have known about that because it's just such an interesting piece. I would have learned a lot more about the process, because that right there is, I always wondered what the hell is a CNC machine for, and what's a lathe for and stuff like that. And some of that stuff is for making these molds. I mean, it's not the only reason, obviously, but you have a really accurate CNC, and you can mill out metal and stuff like that. You can make injection mold with that kind of thing. I mean, you can actually do it with that, and I always was wondering, what the hell are people using this stuff for? And that's one thing. I mean,
exactly. And I'm sure it's changed a lot since, over the last 20 years or something like that.
Yeah,
it's gotten cheaper. It has gotten cheaper. It has gotten better, and there's many different. I'm sure there's many different ways to do mold-ins and get cases and stuff like that.
There's injection molding places all over the world, which means there's some very low cost regions that are doing that kind of stuff.
Exactly.
But your mileage may vary, and you get what you pay for.
And the whole idea of injection molding is so that you can churn them out for next to nothing. if you wonder how the Chinese can do the fart-in toy that costs 50 cents, that's
with
how they do
case,
it. With a fully custom, 5-part custom case, that's how they can do it, because they churn them out for, half a cent each for each half of the case or something. That's how
and
cheap
then
they can be.
They use
in
the
volume.
chip they're paying 10 cents for a micro because they're buying them in the millions, that kind of thing.
And they don't even have a case on them. It's just a bare die or something like that, So
right, and then they put a glob of epoxy on it.
Epoxy on top, and they shave off 2 cents on the product cost.
Yep.
Yeah. That's 2 cents in their pocket. That's probably all they're getting in their pocket. The margins are so...
It's tough, man. It's a tough market.
Yeah, the race to the bottom.
People need their farting toys, Dave. They do. They do.
Anyway, I do believe his name is Demetrius, and he's from Cyprus, and he's in charge of this whole shebang. And it's a lot of effort which has gone into this. So congrats to the whole team who's working on that, because it's freaking awesome.
Yes, it's quite nice.
It's just very impressive. I was impressed. It's not just a bare piece. Most open source hardware projects, it's just a bare Arduino-like PCB or something, and that's it. But when you do a full product, kick-ass product like this, I'm always very impressed.
Well, yeah, he's not shy about the price. That's the main thing.
No,
usually that's the limiting thing, is PCBs can be cheaper. But, yeah, he's not shy on the price, and if you're willing to pay for it, this thing looks pretty nice.
Because you can't just have a bare PCB hanging, you're holding on with your hands just to a bare PCB in the air, or, using some square Jiffy box or something. It's got to be... It's got to be molded.
It's been done like that for years. Come on.
Right, yeah.
Now, if you're going to a show or something, you got to take this.
Right, okay. Yeah. Or would you get more street cred at an RC show if you actually designed your own transmitter?
Oh, yeah. Definitely at a ham convention, you would.
Right. Maybe an RC show, you'd get some dirty looks. What the hell's that heap of crap?
Yeah. Yeah,
You're not using a Futabu or something? Oh,
yeah,
you wanker,
right.
You Yazoo wanker, you. They're probably, brand wars and things like that, so who knows? Yep. I don't know. So if you're into RC, let us know.
Yes, please do. We got one other shout-out this week. This is actually for a previous shout-out, but this is for Kent Lundberg, actually, and... Last time we talked about him, I said he was an MIT professor. He's actually a professor, but I think it's somewhere else. But he is a doctor. He's Dr. Analog on Twitter. He's been doing this site called Reading Jim Williams. And I was going back through it again because he's going through all the Jim Williams app notes, which are absolutely brilliant. And if people aren't reading them, even, like on a yearly basis, if you're not reading one of them, you're doing something wrong. And if you're starting out electronics, this should be what you're working up to. You should be working up to understanding a Jim Williams app note, because I don't get them either.
And they're hard to miss, by the way. I mean, Jim's written over 1,600 pages of application notes, so they're hard to miss. Yeah,
yeah, and his schematics, they just go on. Oh, they're beautiful. They just build up, and he's using like really early linear technology parts. And he uses like 1011s and stuff like that, and but he just builds up some of the most intricate circuits, and they're just building block, and at the end you have page-filled schematics or 2 pages of schematics, and it's all to just measure one thing, and it's gorgeous. It's artwork. Anyways, this shout-out's for Kent Lundberg, because he's doing he's reading Jim Williams' app notes, and he's writing about him, his take on them, and what's good about a certain app note or not. But there is one page on there that is if nothing else, I just found this, and it's you can't miss it. The best app note page, and basically he calls out the top 10 app notes from Jim and why you need to know each one. And this is just like it's like a starter course in electronics, or maybe even an advanced course. And so
I agree. This is a good idea.
Yeah, it really
check it out.
Runs the gamut. I mean, you start with high speed and accuracy and all the stuff you really need to know in analog. And Jim Williams was the master of analog. So.
And he's got and there's like a switch-in regulator with 100 microvolts output noise.
Yeah.
I
beautiful.
Like it. Yeah, so if you got some hours to waste, you can do a hell of a lot worse than browsing through some of these top 10 choice app notes.
Yep.
Thumbs up.
Thumbs up, for sure. All right, so that's what we've got on the shout-out side of things.
What about this kick-ass DARPA grant?
Yeah.
You just, you found
So a friend
this.
linked me to this, and my friend works for a DARPA contractor, and he sent me a link, and full disclosure, this is a little bit of rumor mill, but it seemed like it was on good word, so I thought it was good enough.
Oh,
and even
sorry,
if not,
I just checked the date. It's April 3. So
April 3, not April 1.
Right. So if we are fooled, it's not.
April 3 is that'd be pretty shitty. But if not, this is a new contest that is a grand challenge rather, that DARPA has been floating rumors about. There's no official word yet. Anyway, basically, this new grand challenge is meant to have 6 hardware teams, 12 software teams, and they want to develop a humanoid robot. So, basically, as Dave was telling me before the show, he thinks it's going to be the Terminator.
It is the freaking Terminator. If you listen to what this thing has to do, it's just ridiculous.
So you want to go through the requirements, Dave? What the robot has to do?
Have you got them to hand? No, you had them to hand.
I do, yeah. Okay, so first off...
Here we go. The specific tasks are, 1, the robot will maneuver to an open-frame utility vehicle such as a John Deere Gator. What? I have no idea what they are.
A Gator's like a six-wheeled, like an ATV, or... they were saying like a tractor, but it's like basically a tractor.
And the robot is to get into the driver's seat and drive it to a specified location. Number 2...
Basically use human transport. That's the main idea.
Number 2, the robot is to get out of the vehicle, maneuver to a locked door, unlock it with a key, open the door, and go inside. Screw that. It's the freaking term. Why does it just kick down the freaking door?
That's a good idea, too. I like this.
Why?
Or they could shoot the door with its built-in machine
boundaries,
guns.
Folks. If you're going to enter this, think outside the boundaries. I don't need no stinking key. Boot. You know, I'm a humanoid robot. I weigh 1,000 pounds. Boot.
Right.
Yeah. Number 3. the robot will traverse a 100-meter rubble-strewn hallway. Ooh.
Yeah.
Spooky. At the end of what if there's no electricity in there? Does it have to provide its own lights? Does it have like
I can only
headlights?
hope so, because that would be so cool.
And it has infrared night vision as well.
Oh yeah, right.
And mapping, so like you'd stick a Microsoft Kinect on its head and it can map that. Number 5 is alive, you know.
Yeah.
Oh god. And at the end of the hallway, number 4, the robot will climb a ladder. Doesn't say how tall or whatever.
Right.
It's got to climb a ladder. 5, the robot will locate a pipe that is leaking a yellow-coloured gas, non-toxic, non-corrosive. That's a bummer. The robot will then identify a valve that will seal the pipe and actuate that valve sealing the pipe. And last but not least, the robot will locate a broken pump and replace it. Holy crap.
That's awesome.
Unbelievable. And the robot is to be teleoperated.
Right. So you could either have a human controller, you could have one of those fancy RC controllers we were just talking about. Yep. Who knows, right? This is kind of awesome and kind of scary. I mean, as Dave alluded to, Terminator style, right? If you could do it here, you could do it in an army situation. If you saw this thing
climbing out of a freaking car and coming towards you, you're gonna crap your pants.
Yeah. Oh my goodness. But the thing I was thinking about, so I was reading this, and like I said, this is still grapevine, rumor mill. Who knows if this is really true? But if it is, the interesting thing is they reference Fukushima, right? And it makes sense. Like all of these requirements sound like Fukushima, right? You need to be able to get in. You need to have a humanoid. It doesn't have to be humanoid either. There's no requirement in there as far as I can tell.
To have two legs and 2 arms, right? It could have 4 legs and 4 arms.
It has to do these tasks. It could be a spider type, and that would be even creepier in my opinion. But basically, all of these requirements are get into a nuclear plant and that's been shaken to bits and fix it, or make it safe again. And that's kind of the idea. And there's tons of applications. There's you could firefighter applications, tons and tons of applications. You could just, even human assisting, like assisting the elderly or that kind of thing.
You're sitting on the couch, get me a coffee.
Yeah, or a beer.
Right.
Yeah, iRobot style, right? I mean, what was it? Was that the movie iRobot?
Oh, with
Will Smith and
the iRobot one. Yeah, I was thinking of the Robin Williams one.
Oh, which one's that?
Oh, it's Centennial Man? Bicentennial Man? Is that
I never
right.
saw that. I heard that was a terrible movie.
Yeah, I think so.
But yeah, all of the sci-fi fantasies kind of come true with a humanoid robot. But yeah, now here's the interesting things that I saw in this page, because this is Hizook.com, and I'm not sure if it's supposed to be like off the Hizook. But one of the interesting things about this is there's 12 software teams, 6 hardware teams, but they're also going to open it up to unpaid teams, at least as far as this rumor goes, that could then take the place. So in theory, you could have people working on this kind of challenge for free, right?
Yeah.
Who could then work their way in, which is kind of crazy, versus writing a DARPA grant and trying to get chosen.
Right. Yep.
You just start working on it, and then if your thing's good enough, then you get to take someone else's place. It's almost like a high-tech reality show, but obviously much bigger implications.
You're voted in instead of voted out, right? You're voted into the group.
Right, exactly. And
by that nature, someone has to be voted out too, I guess.
Right.
Yeah.
Regardless, though, I mean, oh man, that would be so cool.
Right. So they're actually have they got the so they're going to actually have full-time design groups working on this thing. Is that the?
Well, this would be like Grand Challenge. So Grand Challenge was also the I think the 100-mile car was also a Grand Challenge thing. That was the solar car.
That's right. Yep. The autonomous car, wasn't it?
Yeah, something like that. It needed to run many, very high mile per gallon kind of rating, or what would it be? Do you guys say kilos per liter? How do you say that there for efficiency?
We say how many liters per 100 kilometers.
Okay, that's actually probably better.
An efficient car might be 5 liters per 100 kilometers, for example. A bad one would be 12, 15 liters per 100 k's.
Right.
Or 100 k's as we call it.
Right.
Yep.
Anyways, very cool, and I think it has some interesting implications from the like biomimicry kind of stuff, right? I mean, biomimicry is the idea that you copy nature, right? So if you were going to design electronics for something that needs to walk into a building, you got to figure everything in buildings is suited towards humans. So why not just build a human type robot, right? But maybe you do build the spider-like robot that we were talking about earlier.
Right.
Or
walks
something.
Upside down on the wall, on the roof, and
something
clings,
totally crazy. Ugh, creepy.
It's freaky shit.
Yeah,
I don't know.
But it seems like a lot of opportunities for some pretty cool electronics. I think. I mean, I'm guessing a lot of the servo drives and stuff like that are out there are pretty well developed, but getting it all to work together, and then the software on top of that, all to work together.
It's crazy. It's a massive undertaking.
Yeah. It's a lot of brain power, but
and it certainly won't be done this year or the next. It's
no.
it's a long-term thing, right?
So
how about some vintage electronics?
Yeah, let's look at that, because they will not be using vintage on these robots.
Right.
So what's the vintage?
I doubt these robots will be using germanium diodes. Dave, DJSB from the forum, posted a link to 40 uses for germanium diodes. It's an article, and it looks like it comes from the 60s or something like that, from Sylvania, if anyone remembers the Sylvania brand. It's an application note kind of thing, and it's got 40 different applications for germanium diodes. It's just really old school and quite fascinating to look through.
Yeah, it's kind of weird to call them out too, not as just a diode, but a germanium diode for the extra
lower voltage drop.
Yeah, the drops and stuff. I mean,
they were pretty horrible. Apart from the low voltage drop, they were pretty horrible diodes, if memory serves me correctly. I haven't used one for 25 years or something, but they were like, the leakage was pretty horrible, and speed and all that sort of stuff was pretty awful, but they were the thing to use for your, whisker radio, for your tin whisker radio or something like that. So, but I don't know. Does anyone still use a germanium diode for any purpose at all?
For like new stuff too, not to just replicate and fix old stuff.
A niche need where only a germanium diode can fill that niche requirement? I'm just curious to know. It wouldn't surprise me if there is some bizarre...
like RF kind of high frequency stuff, maybe.
I don't know. Well, no, I don't... Well, I don't know.
I mean,
No
you and I
idea.
don't really do RF. Maybe
But
Jeff, probably.
that's why I'm asking. Is there still a... And I'm not talking like a new vintage thing. I'm talking,
Right.
It's like you cannot use
Like, you
anything
can't find
else.
anything better.
Yeah.
Right. Because there are components like that, right? I mean, there's stuff out there where you're just never gonna... You're not gonna beat, a MOSFET for high input impedance on the gate, right? I mean, you're not going to beat that for
low on resistance and all that stuff. Yeah,
right,
you're
exactly.
just not going to beat it. So, please, if you know of anything, let us know. When was the last time you used one? Or if you've just seen an obscure application, can you even... I wonder if you search DigiKey. I'm going to search DigiKey right now. This is great on-air stuff.
Oh, yeah. Yeah, people love this stuff. Well, while you're doing that, I should bring up... So this actually kind of reminds me of an article from Jack Ansel a while back about just general transistors, and he actually references the GE transistor manual.
Oh,
and, and he talks about how his eyes are always drawn to, schematics, and that's the first thing that I thought when I was looking through this germanium book from Sylvania. But, like the first thing you look at is, text, schematic. Right, and then you're like locked on there for a while and stuff like that. But there's this he links in this great transistor manual. It's all NPN based stuff, but definitely worth a look because you can especially if you're trying to learn analog and kind of work your way up on the analog side of things, you can get a lot of great circuit ideas, build this stuff up, and then it's just an old application handbook, but it's a great way to teach yourself how it's been done for a long time, and also then you can make the same mistakes and then, learn. Then you could be the old codger in the office and be like, oh, well, I wouldn't do that, And then you're not using a micro for everything either because that's...
True.
I think that's going to be increasingly a problem with upcoming engineers. Like if you're raised on Arduino and Arduino is your hammer, you're going to you're going to see everything as an Arduino shaped nail, right?
Exactly.
Yeah. Yeah, I saw Silicon Farmer on Twitter was talking about that today. He was talking about something like flipping on two LEDs, and he said this person he was talking to wanted to use a microcontroller, and basically he's like, all you need is an SR latch for that. Don't use a microcontroller, especially because you're going to replicate it 50 times. And it's like, holy moly, like people are going to do that kind of stuff, right?
I know.
I mean, I don't know what the actual situation was, but I think that is a very realistic situation that if you grow up throwing a micro at everything, even though there are very low cost and low footprint micros and low power and everything else,
sometimes it's still not as cheap as a 7474 or something like that.
Right, exactly. And or sometimes it's good to just you don't need a timer in a micro. Sometimes you need an RC circuit, right?
Yep.
And so it's good to learn all that other stuff. It's good to have your Art of Electronics book right next to you because you will not be using that for the microcontroller section, I'll tell you that much.
By the way, the answer is no. I searched DigiKey for the word germanium and nothing.
Nothing,
Zip.
huh?
Nada.
Wow. All right, well, that answers that.
So,
yeah.
Maybe there's still a niche market, though.
Well, I'm sure for the older... I mean, I'm sure you can get them online for,
I'm sure you can still buy
surplus
them
or scrap or...
Exactly.
You can get them.
1N54 or something, is it, as the standard
Joe
logs?
3.4 is listed on a lot of these.
Yep.
Yeah. But...
I've probably still got a couple of those in a parts drawer somewhere.
Yeah, and it's a good thing to build with, too. I mean, like a lot of these circuits in the Sylvania one are it's characterizing a lot of it, but also it's showing like pentodes and like tube circuits and stuff like that. So, it's a good experience still.
Yep.
And,
but it was killed by the Schottky diode, right? Because the germanium diode typically had like 0.3 volts drop, but then the Schottkys came along and they can actually get lower than that.
Oh, yeah.
And the germanium ones weren't high power ones either. As far as I know, they only did low power versions. Sure, someone will correct me there. Maybe there's some big industrial germanium diode somewhere.
Maybe. I know that there's a big push on that right now, too, because that drop in like a switching regulator, and I think in inverters, too, I think that drop determines your efficiency. So that's what
it's a big component in your efficiency calculation, for sure.
Right, so people are trying to get that lower and lower. Last I saw something at like a 20 millivolt drop across a diode, which is...
Well, then you can
crazy.
do active ones. You can do active diodes, active rectification, which is another topic altogether, where you have to replace the one diode with much circuitry to get, an
right. You
active
actually start sensing the crossovers, and then you turn on a MOSFET, or you turn on this, turn on that, and then you turn it off, and that's a lot of fun too.
Active rectification. Google it. There you go.
Yes,
that's today's advice. Google active rectification.
Yes. Get the hell out of here. Go Google something. You kids. You darn kids.
Or go to your personal library and look up your application note in your data book.
Oh, my God.
Google it, switch off the computer, go home.
I thought you meant like a local library, like, walk down the street to your
No, you're supposed to have a good library in your
dead tree
lab.
library.
Come on.
Oh, okay. Because I was thinking that would be interesting to go. Like I have, we have a dead tree library here. My community does, and it's quite good. I mean, I live in Cuyahoga County in Ohio.
Ours isn't bad.
Yeah, and I mean, I can get any kind of book from anywhere, but it's always fun to try and see what your local, like depending where you live too. I mean, if you live in like a metropolitan area, usually have Greek books. You could find art of electronics in a downtown library.
Yep.
But like in my suburban library, you might find 1974 circuit book that's like, totally defunct, and it's like, microcontrollers will never take off.
I love it.
Yeah, so it's always fun to see that kind of
things
stuff.
date very. Some electronics texts can really date like that. So
yeah. I remember I tried to learn how to program when I was like 7, doing that, and it was all like basic, and I really didn't have any clue what I was doing. I knew I liked computers, and I just kept taking books out of the library and just being like, I don't know what I'm doing. Why this doesn't seem basic at all.
but it all comes back to serve you, even if you didn't have a clue what you were doing. You were actually learning, even though you didn't realize it.
I learned I hate programming. That's what I learned.
Right.
I learned that I do not like BASIC, and then I ended up using it a lot later. But
right.
Oh yeah,
unavoidable
memories.
Oh boy. It was. I couldn't afford a computer. I had to go to the local store. I had to go to the local Tandy/Radio Shack store to play around with their things. So I'd sit there all day. And,
really? You're like the kid in the music store, basically.
They'd know me. So they Dave's back.
The Jones kid is back.
He would just sit in the hot corner and hog the computer for the whole day. So
nice.
Yeah.
So what kind of space would that be these days? Because those kids are still around. Like there's resource. Everyone's tight on money these days. Resource restricted. What kind of people would see that kid walk in now? Like where does that happen?
Well, we're
and then
not
see
tight
that kid
on
walk
money
in.
these days. We live in an affluent society.
Maybe in Australia.
Most people do. Pretty affluent.
There's still that situation, right? I mean, there's home situations where that kind of thing is. Yeah. But is it still at there's no computer stores anymore, right? I mean,
but you can you can get secondhand computer on eBay for free, right? People are giving them away. But if you're like an 8-year-old kid who's like super interested in that stuff, and your parents don't give a crap, then what, right? That's the situation. I'm not saying your parents didn't give a crap. I'm saying that there is those situations. Really.
Okay, then like they weren't actively interested.
For goodness sake, man.
Okay, so maybe the internet's it then, right? Maybe it's
this whole communications revolution has changed everything.
This kid keeps popping up on EEV blog forums, and he keeps asking questions, and he's going to be somewhere someday. That's the next Dave Jones. That guy's going to be really loud someday.
Loud. Yeah, that's the best thing people can say about me. I'm loud.
Yep.
I love it. Oh, boy. Shit at everything, but I'm loud.
And he's loud. You will hear him, people.
And I did just peek there. I can see the...
Oh, yeah. There you go. See?
But, technology is so plentiful these days. You can pick up anything for free. People are just giving stuff away.
It's true. It's true.
I mean, older. Like, I got my... the computer I'm using in my lab at the moment, I found in the freaking junk bin I found in the garbage room, right?
If Dave's audio cuts out, now we know why.
And it's 4 years old, but it's faster than my brand new notebook. It renders video quicker than my new... Because it was a bleeding-edge computer 4 years ago that probably cost him $8,000 or something. And now it's tossed in the garbage room, and it's perfectly fine.
Hey, whatever does it.
Yeah.
I think electronics people by nature are scroungers. I don't think that's any secret. I mean...
No, exactly.
I mean... so we were talking about Jim Williams earlier, and we've talked about his workbench being at the Computer History Museum. While I did think that, oh, wow, that'd be cool to see that piece of history, I also thought, well, what kind of components could I find on his desk? I mean, he might have some really good stuff there. I mean,
yeah, exactly.
he works for LT. I want to just kind of like dig around, see what
lean over the road, you know.
Yeah, exactly.
Oh, there's the LM10 I need, you know.
Exactly. Yeah, exactly.
Jim would be proud.
And at the end, the whole bench is empty.
Right.
I mean, just like anyone's bench at like an office. I mean, like, oh man, there's always vultures, you know, like at electronics
they
offices.
Come around and they pick through your component cabinets and they pick through your drawers. Yeah, when you're not there, and that's a given. You know, you expect people to do that.
Yeah, it's kind of like a commune in that way.
Yeah,
right?
yeah, it's commune. Yeah,
it's a part commune. I definitely know where all my coworkers keep the box of components.
Yep. No cubicle is sacred in engineering.
No. Oh no. Is that how you do it? How do you store part? You do the notebook where you do like the pages of components? How do you do that?
Notebook?
Like, you know, some people do like the laminated notebooks where they like slide in like SMD components in there.
Oh, right. I've got a few of those, but they came
mostly?
from the manufacturers. They were like, demo kits of SMD parts or something. You know, I don't do those. Oh, I've got anything ad hoc. You know, sometimes at work it'd just be stuff thrown in the stationery drawer, you know, tossed in there. So I'd have the top drawer would be like the parts drawer, and you just rattle through, and and it's all in your head. You know, you realize, 2 years ago I know I tossed that chip in this drawer somewhere. So you run me through for half an hour.
I had a half reel of 317s in here somewhere, right?
Yeah, exactly.
Yeah,
and yep.
And if you see a half reel of 317s,
I can remember shit like that, but I can't remember, you know, what I had for lunch yesterday.
Yeah, it's just how your brain's wired, right?
Yeah, exactly. You know, stuff that matters. Yeah,
exactly.
You know, you're a nerd. Yeah, that matters that you put that half reel of 317s in that drawer 3 years ago. You know.
Yep.
That shit matters.
Yep.
But something your wife told you had to do today. Nah, that's just in one ear out the other. Right?
Well, yeah.
I think she's listening. Could be in trouble.
Oh, she probably. Yeah, she's got a cup to the door right now. She's like, "Oh, Dave."
You had a bit of a rant here about Maker Faire.
Oh, not that big of a rant. It's just
when are you going, by the way? You said you were going to...
I am going.
And you were going to check out Jim Williams' bench, weren't you?
No, I'm not going to be able to because that's actually closing up the 15th. I'm not sure if it's just going to not be a featured exhibit anymore or if it's actually going away. I'm not sure where it would go.
Well, maybe it gets stored in the back room for a little while. Maybe you can speak to someone there and they might be able to give you a special
I'll have to do some research on that.
I'm from the Amp Hour. I'm important. Let me in, you know?
Yeah. They punch me in the face and walk away.
Right.
Oh, boy.
Yep.
No, I'm going to be out there. I'm heading out the 16th of May, and I'll be there till late on the 20th. So,
but you still have to go to the Computer History Museum, dude.
Oh, I know. Yeah, I totally have to go to it.
Right.
Because I've never been.
Right. Is the wife towing along, or?
I will be there solo, but hanging out with some good friends. Mr. Kaiser will be there. I'll be hanging out with him. So
cool.
Yeah, and a couple of a lot of other people. If people are going to be out there, let me know. I'd love to know that. But yeah, there's this thing that's kind of going on there, which is kind of different. I don't know how I feel about this. It's kind of weird. It's kind of Maker Faire is great, right? Yeah, Maker Faire is great. It's this, if people don't know, Maker Faire is a 2-day kind of like carnival for technology. Not everyone knows, Dave. Don't assume here. It's like a carnival for technology, though. A lot of makers are out there. Yep. That's where the term makers come from, basically. But yeah, so that's the Saturday, Sunday. I'm going to be out there a little earlier. But there's actually this a workshop that's starting. It's like $775.
And therein lies your gripe, right?
Yeah. Well, I mean, I'm more curious about it. I mean, so great speakers list. I think it's the 15th and 16th that'll be going on. But I'm just not sure why. I mean,
because that's how these companies make money at these carnivals and at these trade shows and conferences.
Maybe why is
stuff.
The wrong question then? Why is the wrong question? It's who? Who is the question, I guess?
Well, you've got to pay these people who come and speak, right? Most of them won't come. Most of them aren't nerdy enough to come and speak for free.
No, I know, but who's going? That's what I'm wondering. I mean, maybe some of our listeners are interested.
Well, most people don't fork out their own money for stuff like this as businesses.
Oh, well, if that's the case...
Businesses pay for it. That's how trade shows work. That's how conferences work. Companies just, $1,000 or $2,000 or $3,000 for a 2-day conference is nothing to a company. It's just
that's
chicken
true.
feed.
Yeah.
It's just written off on the training budget,
Yeah, and I was so surprised about that. I remember I went to ESC the first year, and I saw the price, and I'm just like, holy crap! Yeah, they have a free pass for like the
just to get in the hall, right?
Yeah, like the show, and you can see the show. But if you want to get in the classes, man, you are paying. And the thing is, companies happily fork it over because they want you to learn about stuff, right?
That's right.
And it's really kind of captive audience, and you can't learn that stuff anywhere else. And so you're willing to pay. I mean, companies are willing to pay it,
and they're usually pretty good. I've been to quite a few of these, and rarely have I been to a bad one. It just doesn't
you always
really
learn
happen.
Something.
Yeah,
you always learn something.
Because they always usually have like big name, reputable people, taking the courses and stuff like that. So
yeah, that's true. I got to see Bonnie Baker from TI at ESC last time. I mean, I've taken Jack Ansell's classes. I mean, lots of great people there. So, but boy, that's a lot of money.
$775 is not much in the scheme of things.
I guess not.
But considering that Maker Faire is not really business oriented,
that's the question.
Can imagine you trying to put through the purchase requisition for I want to go, or training requisition, budget requisition to go to the Maker Faire.
Right. It's like, I want to start my own open source hardware company someday. And then my company looks at me and says, when now? What now? I'm not sure we're going to pay for that, buddy.
Next thing you're in corrective performance counseling because you're not being a company man.
Never heard of that one. Is that
corrective performance counseling, yes.
or also known as the Dave Jones class.
We
designed this curriculum around Dave Jones.
They just gave up sending me to that sort of shit because I could not be corrected, Oh, boy. I would end up counseling them. Yeah.
Oh, yeah. Let me tell you something about what it is. Yeah. Oh, that's great.
But, dude, you get a free continental breakfast. What are you complaining? You probably get lunch, too. What are you complaining about? It's worth it.
No, maybe. That's the pricey lunch. But it's really, you know what it is? And this is another thing that I never knew when I was, when I was in school.
There's beer.
No, it's not about the beer either because and like they even said, it's craft beer here. That's cool. It's not about that. None of these things are about that. All conferences are about, and even Maker Faire. I'm really excited to go to Maker Faire, but I'm just so excited just to go and meet people. It's so anti-engineer stereotype.
You're an anti-nerd. You really are.
I know. No,
real engineers and nerds don't want to, and hackers don't want to meet other humans.
I will bring balance to the Force,
humans.
Dave.
Right,
I will bring balance to the Force.
Probably
not, really. But yeah, it's even if you shyly talk to someone about their project and that kicks off, that's all that matters. Just learning about other people's projects and talking to people and getting to know them and being able to communicate later. Communicate's the wrong word, right? That scares people off.
Speak to humans, I do not want.
It's just no. You even talk. You talk to people. You talk to at least. I know you talk to at least one other engineer a week.
Yeah, right. On some anonymous show. Yeah, I know.
Yeah.
I dig where you're coming from. But yes, it is anti the stereotype. It is totally,
Yeah.
And I've been to a lot of these. A lot of engineers, they don't want to chat. They're hiding over in their corner, just eating their free lunch and just, trying to, they don't want to mingle with the other humans.
Yeah. And there's a book that's called I think it's called Never Eat Alone. I'll try and link it in. But
that's where we all come from. We're all nerds. We're all shunned in high school, right? So in the cafeteria, you were the nerd sitting in the corner eating alone, right?
Yeah.
That's
talk about the anti-engineer book right there, right? But because, even like Woz talks about, engineers should work alone. Good engineers work alone, that kind of thing. It's very contrary, just how a lot of it happens. This Never Eat Alone book, of course, is a business book. It's about, you should be networking and doing this and that.
Wank.
But here's the thing. If you take out all of the, networking and all these buzzwords that suck, right? Never eat alone. Oh, that sounds horrible. Like, sometimes I want solitude, right? I'm like that too. The thing is, getting to know people, like, that is so important. So, because if you start a company tomorrow and you have this great widget, you got to tell someone about it. And if you just shout about it really loud, no one's going to listen to you. So even if you're just, talking to someone that is mildly interested in technology, you keep in touch with them, and then you never know who that person might know or what they, what they might even be working on. So and from the engineering side, that's the exciting part too, because you might be talking to someone about this great project you're working on. They're like, oh yeah, I've written tons of firmware for that kind of hardware before, right? That's like a big deal right there. Or I know my buddy works on that kind of firmware, so that's the reason to do it. I don't know. Rant
you
over.
just grew up in the communications age, dude. I grew up when you couldn't contact people like that.
Well, yeah.
I grew up where, I was alone in my lab, and that was it. That was my whole world, because the rest of the world may as well not even existed because you couldn't contact them.
Right, and there is I wouldn't envy that kind of situation, because it would be very frustrating, and to be honest, that's what gives you a lot of your tenacity, I'm sure. In figuring out electronics and stuff like that, because you couldn't just go look it up.
No, that's right.
I wouldn't have wanted to do that, but man, I think engineers from back in the day were definitely. They had to have that grit and resolve, right? I mean, I think there is a molding face of engineer, because back then you did it or you didn't, and now it's you did it or you didn't, or you looked it up online, or you talked to someone else, and there's a lot more ways to try and get stuff done. So I'm not sure I would have been able to make it back then. So.
you would have gone into marketing, huh? Sales.
You never know.
Yeah.
You never know. Yeah,
Too
my
much
whole
of a people
family.
person.
My family. I come from a family of salesmen, but
oh, there you go.
Yeah. My dad's a salesman. My grandfather's a salesman.
That explains everything, folks.
Yeah.
Yep.
I didn't want to be a salesman though, and I like technology. Engineers don't travel. Salesmen travel. I don't like traveling, so that's a big deal. Anyways,
all right. Let's move on.
Yes. Speaking of talking to people and helping friends out, I actually did this past week. So I had a friend who contacted me, and he was asking about low-pass filters, and he was working on a detector. And I actually finally used a schematic/spice sharing program. This is
sacrilege.
I know. Because I could have just drawn it up in LT Spice, right, and mailed it over to him.
DaveCAD.
Or DaveCAD, and I could have taken a picture of a Post-it note and emailed it to him, or
that's right. That's the efficient way to do it.
Into a paper airplane and tried to fly it to him across the country. But instead, I used Circuit Lab. This is the thing we've talked about before, the online spice.
From the Nerd Kits mob, right?
That's right. Yeah.
Yep.
Yeah. So we talked about this a couple weeks ago, but
it was. Did it work? B, was it useful?
It did work. It's hard to tell because it's on top of the. I don't know.
It's hard to tell if it worked.
No, it's not hard to tell if it worked. I mean, the output of the. So I was doing just a Bode plot, and the output looked like what I thought it should.
Bode?
Bode, yeah, like a magnitude and phase.
Bode.
Really?
Yeah.
No. Oh boy, here we go. All right, keep talking.
There's no I on the end, dude. It's Bode.
It's Bode. See, you would have known this if you would have gotten out of your the electronics shack when you were a kid, but I'm pretty sure it's Bode.
It's Bode here in Australia, mate.
Yeah, unless it's the guy's name. Oh, it's Jones? No, I pronounced your last name Jonas. I mean, really? I mean, if it's a guy's name, right?
Boy.
Heinrich Wade Bode. Let's see. There's his thing. Bode. There it is. Heinrich Wade Bode. In English, Boda in Dutch.
In Australian, Bode.
Bode plots. Okay. And another one bites the dust, folks.
I don't know.
This guy was a badass. Yeah. Ohio State University, Bell Labs, Harvard University. That's pretty awesome. And Columbia, too. Wow.
Got around.
Yeah, he did.
Wow, this is one whore.
Yeah, this is one hell of a CV here. Check out his. I'll link in his wiki page. This is impressive. Where was I going with this?
Is he still around?
No, he's long gone. He's
long gone.
I'm sorry to Bode's family. He passed away in 1982, sadly. But yeah,
see, that's fairly recent.
82, Dave. I was born in 83, man. Fairly recent.
It's fairly. That's somebody on Twitter. I think it might have been Alan. He tweeted something. Alan Yates. He tweeted something the other day. I think it might have been him. Sorry if it's not. Tweeted, and he said something like, 1996. I always think that's recent. 19, and you look, and no, it's like
No, sorry, folks. That's 22 years ago.
You know, your fingers come out. You start counting the decades. You know, and
no, that's not even right. Sorry.
And it's like, oh my goodness, yeah. Just means we're getting old. That's all.
My math was totally wrong there, but yeah.
Well, no, right.
Yeah. No, 96 to now would be, what, 16? 16 years ago? Yeah. Yep. People born in 96 might be listening right now.
Oh, they
were laughing at that. And, but they're driving, too. Get that, right?
Right, yeah.
Yeah, that's crazy.
That's scary.
Yeah.
Oh, boy.
All right, so back to Bodhi. Bodhi? Are we going with Bodhi? Yeah, we're gonna go with Bodhi. Impressive person, to say the least. But I was doing a Bodhi plot for a low pass filter. He wanted to do an active filter, so he was looking at like a Sallen key topology.
Yep.
Which I really didn't have a lot of experience with. I'll be honest about that. I mean, I do analog, but I was always doing like low level DC stuff, so filtering wasn't really my cup of tea too often. You know, like higher frequency filtering. But he first off, he pointed me to a great
higher frequency being like audio.
Yeah,
you know?
above 1 hertz.
Yeah, exactly.
Yeah,
yeah. I know it's that's like. Yeah. High frequency for me was 2 kilerhertz. Used to be.
I know, right? And right now there's some ham operators and there's some RF people just like screaming and spiking their iPods.
2 kilohertz audio, that comes out of a battery, doesn't it? Yeah. Battery gives out freaking audio.
Oh, man.
Frequencies, you know?
Yep.
Yeah. It's, yeah. Anything under 100 megahertz rounds down to 0, right?
I know, and that's crazy because people do that. I mean, they say that kind of stuff. Anyways, so first off, there's a really great app note he pointed me to from TI about Sallen key filters. You know, active. You can do multipole filters and stuff like that. So there's that. But I was actually using it in this Circuit Lab software, and it worked out pretty well. I mean, I put in my own op amp. I wanted in like a high bandwidth op amp with a lot of gain, and so I put that in. You know, I just typed in the parameters. Sorry.
Oh, you typed those in, so you couldn't choose from a part library?
You could, but it was just a real limited part library, so it was just easier. And you know, it's not going to be an advanced thing, so you could tell right there. You know how like op amps in Spice can have like level 1, 2, 3 of different.
Yep.
It's all different math underneath and stuff. And if you really want to get specific, you need to go to like level 3 stuff. But this was very high level.
Yep.
So.
Which is just fine for a top-level filter. You just want to see if the topology works. And,
right, exactly. I was just playing with values, really. So I hooked up capacitors and resistors and, you know, did the feedback and everything. And it was great. I mean, it worked out like I expected it to. It output a Bodhi plot pretty well. And
you do realize there's specific filter programs. Like a lot of the major manufacturers, Microchip and various others, do filter-specific simulation programs, and they're rather neat. I love a tool designed for the job. You know, it's
and that is nice. And that's for like designing a filter. But I was actually not designing a filter. I was trying to help him with a question about if gain changes the frequency response, which it does. I mean, especially around the knee frequency, and so I was trying to show that, and then show how you could change values and stuff like that. But overall, I mean, it was pretty good, and I'll actually share the schematic I drew up. I mean, I can do that with people on here, and maybe that's a good thing for us to do on here because we can just pop in circuits people can easily simulate. So, I'll share it as a link in the show notes, and people can try it out and see if they like it. You can't save your own unless you have a account, which we talked about before. So I actually got an account.
You're registered. Yep.
But I turned off the email stuff, so they're not going to send me emails, hopefully. But yeah, overall, not bad. I mean, there's some stuff that can be approved, but overall, I was impressed. And there's another one, too, for schematics. If you have, like, a KiCad schematic, you can actually do that in Circuit B. If you want to just share the schematic. And it's kind of like a PDF for schematics where you can actually zoom in and select components. And so it's kind of just one step above PDF, but they're looking at doing some other stuff with that, I think. So that's another tool people can check out if they're interested.
Excellent.
Yeah.
Circuit B is still in alpha.
Is it?
Yep.
Okay. All right, so
some
speaking of
do that.
What, they keep it in alpha for a long time?
They keep it in alpha for like 10 years, yeah.
Oh, yeah. Yeah, like Gmail was in beta for God knows how long.
Exactly.
So, speaking of circuits, we should probably skip all this other stuff that's on our list because we always do that, and talk about our contest from last week.
We have a winner?
We do. We have a winner. Yeah. And I have to pull the person up. Great. All right, so our winner from last week.
We have a winner.
What's that? Oh,
it's been plucked out of our backside.
Oh, yeah, well, randomly. But we had asked people last week to submit a potential chip for Chip of the Week, and we put everyone who submitted into a hat and pulled someone out, and our winner was, drum roll please, Lauren Taus. And the chip that they mentioned was the AD8555, and that is a programmable gain amplifier, or an attenuator in this case. But basically it's for doing sensor-type work, something near and dear to my heart. And
it's got a low offset voltage. It's only 10 microvolts. It's got a built-in DAC.
Yeah,
for
so you can do
actually
that
set in the gain. It's got a digital input. It's got a digital output. It's got a clamp-in input voltage, which is handy sometimes if you need to clamp to a specific voltage rather than to the rails,
Yep.
Or 0.6 volts above the rails, which is how you'd normally do clamping. On a lot of circuits, having a V-clamp voltage is nice, and and it's got some built-in digital, and it's got some weird capability to actually detect open and short wires. So, which is
like
really...
current flowing out of the output or the input basically would be like a short on the input.
Yeah.
And,
so neat.
Yeah. Pretty cool looking part, I got to say. I like it, and we weren't choosing based on parts. It just
$4.86.
Well, yeah, but we weren't choosing based on part. Like submitting for this because some people did submit. This, like AT Tinies I saw on there, and some people did 2N quad 2s, that kind of thing. But this just so happened that this was actually a pretty cool part, so that worked out well. So this is our chip of the week as well. So congrats to Lauren, our first winner of whatever the heck we were calling our contest.
Yeah, nothing. And but so, what does he win?
He wins. So he wins. Lauren wins a
Freetronics
Ether Mega Arduino-based or Arduino-compatible kit. So it's a built-in Ethernet connection and Arduino-compatible
I have one of those. It's very cool
headers.
board.
And yeah, it's great. It's great. So congratulations, and thanks to John and Mark from Freetronics. That was great. And maybe we'll do another contest in the future. We'll see. Next time, I think we'll do a Google Docs spreadsheet or something a little simpler. But it was good.
And I have to admit that wasn't a bad way to do it, rather than put everyone's name in every listener in the hat. Yeah. Only those who sort of emailed it,
contributed. Yeah, a little bit of effort, not like a ton of effort. And we'll see if it ever gets any more complicated. Last time I tried to have it's tough having a riddle, like a word puzzle, basically, for electronics.
I don't like that. That sucks.
Especially ones that people haven't already heard before. Like I can't just go and look it up online because everyone goes and types it into Google. And it's like, so.
I can remember contests back in the electronics magazines, and they do silly stuff like you had to make a funny technical poem or something like that.
Oh, I like that. Dave might have just come up with a new one there.
No, God, no.
Limericks, electronics limericks.
Oh no.
Oh, that would be great. There once was a man named Resistor.
Yeah.
He had such an ugly-ass sister.
Good. Well, it doesn't rhyme, but it's Millie Henry,
Yeah.
Yeah. No.
All right.
Let's not. Please.
Come on. All right. Well, we got anything else for this week, Dave?
I don't know.
One last thing? There's a section I wanted to do on the amp hour, and this might be a little too long to jump into now, but design tips, actually. So, like, stuff that Dave and I have encountered, if we can try and talk about it on radio. But I'll try and call it out now just because there's a lot of, like, general topics that either younger people that are getting into electronics need to learn about, even just to call them out so people can go do more research. And one big one, and something Dave's done videos on before, and is something that confused me for a long time. Yeah, switch mode power supplies.
Oh, yeah.
Yeah, so a lot of people don't, you start in electronics, you're kind of doing linear regulators, and then you realize, wow, these burn a lot of heat. But switch mode, there's actually this really great app note from Microchip that I saw on switch mode power supplies, and maybe that's just all I'll link in this week. But maybe design tips as a section of the amp hour could be a thing in the future as well. Talking about I don't know, because there's a lot. There's a ton. I mean, really, switch mode is a huge field. I mean, you could be a power electronics engineer right there.
It's massive. Yeah, I know.
Right, but like we were talking about before.
My video on switch modes was how that they're actually not that dissimilar to how linear regulators work. And I did the comparison in the video where a lot of people don't know that. They're actually
with like the
an
feedback
identical
and
topology. Yeah, they're an identical topology to linear regulators, except that, you'll have to go watch the video to see it.
There's the teaser right there.
Exactly. I'm not going to give it all away, but they're actually... And I show how they're can be identical topologies.
Hey, tell that person the contest is over, Dave. I'm sorry.
Right. No. Yeah, you can't enter now. Sorry, dude.
Sorry.
All over.
It's over, Randy. But yeah, switch mode. I mean, it's not as scary as it looks. And we can talk more about that in the future. But for now, watch Dave's video and check out this app note from Microchip, because they're both very good resources to start with. I guess that's not really a design tip so much as a design pointer.
No, it's not. Yeah.
Go over there. Look over there.
While we scurry away.
Yeah, right. And scurry we shall, because our amp hour is up. Yes.
It's gone.
Yes.
Next week.
People can find us on Twitter, on Facebook, on Google+, and they can always email us at theamphour@gmail.com if they've got any questions, comments, or want to send us a limerick. Not for a prize, though. All right, Dave.
All right. I've got to go pack my microcurrents today.
All right. That's exciting.
It's very exciting. There's nothing I like more than packing and shipping.
Shipping. Got to ship it.
Well, I can't ship today because it's a public holiday here today. So sorry if you're... Yeah.
It's candy day. It's candy day there.
Candy. Oh, boy.
All right, guys. We'll talk to you next week.
Bye.